started from the inside out.
So the Tacoma Power is the citizen-owned utility to serve the electricity through the not only city of Tacoma, but adjacent cities like University Place, Fillcrest, Lakewood, go beyond the JBLM and more southern part of it. Started in 1920s with the citizens who wants to provide to the electricity. We started the senior project with the Seattle University. It's the first, I'm alumni of the Seattle U, so I got invited for the last 10 years seeing the senior projects, and then as an engineering manager I saw the opportunity where there's a protection projects where rather than hiring a consultant, I was going to work with the senior students who have valuable analytical skills where we could utilize it.
Hi, my name is Greg Gordeski. I'm a professional engineer at Tacoma Power. So a growing concern we had with our downtown system is that we have two substations feeding through two duct banks with a multitude of cables going through those two duct banks. And as they get loaded, the cables can heat up and they will actually co-heat against other cables. So currently in a situation where we're concerned about overheating, we've established certain fairly hard, very conservative limits for the amperage on the cables. So our dispatch will be monitoring as they always do, and if we hit overcurrents, the assumption is that there may be a problem of overheating the ducts, and to prevent the damage and what could be a very, very long, weeks or months outage, if a fault fire has occurred because of the overheating, the solution is to clear the bus and simply black out downtown. This situation hasn't occurred yet, but obviously this is a very less than ideal situation, because to black out a downtown of any city looks bad for the city, looks bad for the power company, and looks bad for even the businesses that are getting blacked out because they're they're trying to provide a service, and to suddenly they have to deny service to everyone because they can't even have their lights on is unideal, to say the least.
So to prevent this worst case scenario from occurring, Tacoma Power needs to, well, for one, manage their loads based on real-time temperature data, and at the same time prevent any thermal runaways. That leads us to two major engineering challenges. One, how are we able to measure continuously along a line? And also, how are we going to be able to measure if we can't even measure directly on the line? That led us to something that's called distributed temperature sensing. So what DTS is essentially able to do is, with a regular old fiber optic cable, we can measure temperature continuously along that line. And the way it works from a high level perspective is setting light pulses down a fiber sends backscattering back to the box, and we're able to know, based on the change in frequency and intensity, how hot every single spot is and where it is based on the delay of that signal. So real-time thermal rating is being able to dynamically rate the system in real time. What that basically means is I can measure temperature at a distance, and as long as I know the thermal conductivities of every single material between the conductor that I'm sensing to the thermometer itself, or the temperature monitor itself, I can know the temperature of the system.
So this solution will be helpful in many ways. It'll allow us to pinpoint problem areas, in particular heating maybe due to problems with grounding or anything, or neighboring utilities, things like steam lines, things like that. It'll also give us be able to establish proper thresholds so that we know when we might actually be approaching danger, give us early warning so that we can begin proper load management and load shedding, even to the point of calling customers with generators to give them time to ramp up the generators so that we can unload their load temporarily instead of arbitrarily cutting off feeders or cutting off certain customers.